Hey y'all, welcome to Chapter 2, which will be all about organizing and summarizing data. Now, last chapter, we talked mostly about the vocabulary of statistics and how we will go about doing statistics. In this chapter, we're going to be talking about how we'll display statistics. Now, thinking about how you might display something might invoke the thoughts of bar graphs, pie charts, and etc. In fact, you're hitting the nail on the head. That's what we're going to be talking about. Section 2.1 will begin by talking about organizing qualitative data. Now remember, qualitative data is going to be describing some quality. That's opposed to quantitative data, which describes numbers. Qualitative, quality. Quantitative, numbers or quantity. So, question to kick it off. How can we organize and summarize qualitative data? Well, great question. Let's think up a scenario that involves qualitative data. Maybe you want to poll your family in what kind of food you want to eat. Whether it be, let's say you're deciding between pizza, tacos, and chicken. Well, how would you conduct that poll? You'd probably just have everybody raise their hands when you call out the food of their choice. So, for instance, chicken might get 3 hands, pizza might get 2, and tacos might get 5. Now, that would be pretty clear who the winner would be. You just call out the majority. But how would you display that? Well, maybe you just do tally marks. You say however many people voted for chicken. I think it was 3 tally marks. Could be wrong. And you just tally it up. So 5 would go next to tacos, for instance. Now, that whole act of displaying your tally marks next to the category or the quality that you're after is just the act of doing a frequency distribution. So a frequency distribution. This will be something that tracks how often certain answers appear. So like I said, it literally is just something that kind of looks like quality over here, or category might be a bigger word. And then on the right-hand side, we'll put frequency. But in reality, I want y'all to think about tallies. So, for instance, it could be taco, 2, pizza, 3, and I think I'm getting it all backwards what I said. Let's say chicken, 5. Bam. There's your first frequency distribution. Just shows how many people voted for each category. That's all it is. Now in class, I typically like to do this game where I'll actually just take votes and we'll do one and make one up as we go. But in lay of this, since we're doing recordings, just notice the category and the frequency table we already did. Now something might be more useful than, say, just a regular frequency table. For instance, notice in this table right here that we have, I didn't really give you percentages, let's say. You do have that chicken had the most amount of people vote for it, but by how much? Well, let's think about how we could maybe do something like that. Maybe a way that you could figure out percentages is by, well, first off, we need to know the total people responding, right? Because right here we have 5 people voting for chicken, but 5 out of how many? If it's 5 out of 5, well, that's 100%. If it's 5 out of 100, well, that's 1 over 20. So I guess, 5%? Wow, there we go. I'm a math teacher, I promise. Well, inherently, what you need to do here then to figure out how many people there is add all of these numbers together. 2 plus 3 plus 5 tells me that 10 people voted in this scenario. Knowing that 10 people voted, it actually becomes easy for me to take this and convert all of these 2, 3s, and 5s to percentages. In fact, we could say 2 out of 10 voted, 3 out of 10 voted, and 5 out of 10 people voted for chicken. Now, if we wanted to make that into a decimal, which is close to 2%, we would say something like 0.20, 0.30, and 0.50. So hey, at last I know 20% voted for tacos, 30% voted for pizza, and 50% voted for chicken. Now, this side on the left-hand side is a frequency distribution. It tells you the actual number of people that voted for something. If instead you prefer to display the percentages, 20%, 30%, and 50%, what you're doing is creating a relative frequency a relative frequency table. So, relative frequency is literally just the percentages. Frequency is the total number of people that voted for something. Relative frequency is the percent that voted for it, or the proportion if you prefer that word. Now, importantly, whenever we're doing percents in math, we will be using decimals to represent percents. So 27% will be represented by the decimal 0.27. 83% would be represented by 0.83. 7% would be represented then by 0.07. You take the invisible decimal right here and you bump it forward twice. In a similar way, 100%, take this decimal, bump it forward twice, is analogous to 1. So 0 is 0%, 1 is 100% when we're talking in decimals. Now, why do I bring this up? Well, it turns out that relative frequencies, when represented in their decimal forms, will always add up to 1. That's going to be an important thing to notice on your relative frequency distributions. Speaking of that, a relative frequency distribution is just going to be a table, a 2-column table, where you have categories on the left and you have percentages or decimals on the right. So what we'll call those is relative frequencies. So given our last example, we would still have chicken, tacos, and pizza. And just to make sure that I'm doing it right, chicken had 50%, tacos had 20. It would look like 0.50, 0.20, and pizza had 30%, 0.30. That's what a relative frequency distribution will look like. Category followed by its percentage or proportion. And by the way, notice right here, I've already mentioned it once, all relative frequencies will add up to 1 if you are a legit relative frequency table. And you can test that right here. Now, like I said earlier, if you were given, say, a frequency table and you wanted to get a relative frequency table, it's very important to know how many people actually participated. That's the only way that you can figure out what number leads to what percent. So in the last example, we added all of the frequencies together to get that 10 people voted in our food survey. Well, that's going to be a common trend. If you ever want to get the total number of responses, add up all the frequencies, meaning add up all the tally marks. Seems kind of simple when you word it, maybe not as mathy, but sometimes mathiness is encoded in stats, so it's up to us to decode it. Add up all the tally marks or frequencies to get the total number of responses. Once you have the total number of responses, divide the frequency by the total to get the relative frequency. All I mean, if I can zoom back, is in order to get 20%, we took the frequency of 2 and divided it by the total of 10. In order to get 30%, we took the frequency of 3, or the tally of 3, and divided it by 10. Yet again, the total. And 55 over 10. Now let's go ahead and do this one right here. A national survey asked people, how often do you eat out for dinner instead of at home? The frequencies are as follows. So you can see on the left-hand side, we have responses, which is category of never, rarely, sometimes, most of the time, and always. Now on the right-hand side, we have frequencies. So we have the total number of people that voted for never was 287. The total people that voted for rarely was 376, and so on and so forth. First question, create a relative frequency distribution. Now, typically with a relative frequency distribution, you would actually start by just recopying the response table, or column, excuse me. So I could just recopy response and also we're going to put relative frequency as our second column instead of frequency, so I'll go ahead and write that. Relative frequency. So our responses were never, rarely, sometimes, most of the time, and always. I hope I don't get too jammed up here. Oh lordy, yeah, it's going to be kind of tight. I apologize. Okay, so first off, create a relative frequency distribution. That means I want the total percent of people that voted for each category or each response. Well, 287, that could be a really big number or a really small number. The only way to find out was 287 out of how many individuals. So first step first, add up all of the frequencies to get your total people that participated in the survey. Now I'm going to my calculator right here. If I do 287 plus 376 plus 990 plus 398 plus 13, I get 2064. This tells me my sample size, which we'll call lowercase n, is 2064. Great. Now, in order to get the relative frequency, all we're going to do is divide each frequency by this total number right here. So, for instance, the relative frequency of the never response will be 287 divided by 2064. Now, I will be doing that because I'm kind of running out of space, so apologies for my sloppiness. But yet again, going to my calculator, 287 divided by 2064. And notice this long string of decimals that I get. Now I'm going to stop it. 0.139. I'm going to stop it at the 9 right here. So we'll go 3 decimals for everything as of right now. All we do is we keep going down the list. 376 divided by 2064. Well, go to my calculator. 376 over 2064. I get 0.182. So 0.182. 990 divided by 2064. I get 0.479. So I guess my rule's kind of already breaking. Let's round that to 0.480. Because that's 6, well, I'll go ahead and round up the 9, which rounds up the 7 then. So we already did this, 2064. Now we divide 398 by 2064. So 398 divided by 2064. Okay, we get 0.193 when we round. 0.193. And last but not least, 13 divided by 2064. And feel free to do this at home. Okay, we got 0.006. Perfect. Now, typically on my exams, I'll say go ahead and round to 2 decimal places. And like I claimed last time, you should have that everything adds up to 1. Now, since we are using decimals instead of these fractions that we found right here, if you added up all of the fractions that I just boxed, so for instance 13 over 2064 plus 398 over 2064, so on and so forth, that sum will always be 1. However, since we're using decimals and we are rounding, this sum right here will be very close to 1. On my exams, I'll make sure that it is 1 just to not trip you up, okay? But we just made our first relative frequency distribution. Awesome. That is it right here, over here. Now, just as something that we can find here. So, for instance, if I look over at the relative frequency distribution, I could tell you now that 18.2% of individuals voted rarely. Formerly, I could only tell you that 376 individuals did. As far as the always population, I could tell you that 0.6% of individuals voted for always. And remember, that's because we take the decimal 0.006 to convert it back to a percentage, move the decimal twice, giving you 0.6%. Now that 0.6% that we found only represents the sample that we took. It only tells us about the 2064 people, what percent of this group right here voted for always. What if I up the ante? What if I state that 0.6% of all people in the nation, not just 2064. So 0.6% of all people in the nation always eat out. Is that descriptive or inferential? Turns out, once I bump it beyond something I've directly found, and I use it to try to make a guess as to the population, we're going to be living in inferential land. You're inferring something there. Now, one last thing that I will point out, since we have a frequency distribution and a relative frequency distribution on the same page, is notice that if I just gave you the relative frequency distribution, you actually could not tell me how many people partook in my survey. You could only tell me that, say, 48% of people voted for sometimes. So that is one way in which frequency distributions are a little bit better than relative frequency distributions. Frequency distributions allow you to add up the frequencies to get the total number of people in the survey. If you add up everything on the relative, you just get one, which is 100%. So not really info as to how many people partook. Now this leads us to display. So once we have either the frequencies, the tally marks of how many people actually voted, or the relative frequencies, the percents, how can we display this in a nice, easy to read manner? Well, as we already talked, let's do it through bar graphs. Now, by the way, I'll probably slip and call it bar charts, but tomato, tomato. So a bar graph. All we're going to do on a bar graph is on the x-axis, the horizontal, we'll label the categories of data. So for instance, blue, red, orange, yellow, green, pink, purple. Versus the y-axis, we'll either label with frequency if we're doing tally marks, or relative frequency if we're doing percents. And when we do this, we'll draw bars representing each category, where the height of the bar represents the either frequency or relative frequency of that category. So here you can see two different bar graphs representing the same thing. On the left hand side you see the frequency, on the right hand side you see relative frequency. Now importantly on exams, the thing I'll be looking for is that you have clearly labeled horizontal and vertical axes, and that the bars are actually representative of their frequencies or relative frequencies. For instance, if blue had 10 votes over here, make sure not to draw the bar like this high. That's where clearly labeling something comes in play. Now sometimes it's, especially when you have a lot of categories, you want to have an ordered bar graph. Hey, I just want to know from left to right who had the highest votes and who had the lowest votes on the right. This would be a Pareto chart. A Pareto chart is just an ordered bar graph, where bars are drawn in decreasing order in frequency or relative frequency. For instance, below you can see some poll that we have here about, I guess, different types of ways to spend money, maybe? I don't know, it looks pretty random to me. But you can see that it's going to be a frequency chart because of all these numbers right here. And they were helpful enough to even throw the percents on top, kind of giving you both frequency and relative frequency. The important thing about a Pareto chart is it's ordered in decreasing order. So you can see that we're going downhill as we go from left to right. yet again, make sure you're clearly labeling stuff. A nice way of comparing data from the same categories from two different groups or times would be side-by-side bar graphs. So for instance, in this chart, we yet again have frequency on the left-hand side, and we have all of the categories on the horizontal axis. In this case, we're comparing Asia to Europe to the USA, and their answers for either hybrid, SUV, sedan, sports, truck, or wagon. So when we do this, it's kind of a good way of comparing different groups. So for instance, you might see side-by-side bar charts of men versus women, or certain age groups lined up next to each other. It turns out that you can even do a bar chart sideways. Now, I'm not really going to be requiring this or wanting this. I like the vertical ones better. But hey, if you have long category names, you can flip it on your side if you really want. Please do it this way. This is a lot more standard. But if you absolutely need to, it's an option. Last but not least, probably everybody's favorite will be pie charts. Hey, you take a circle, divide it into sectors where each sector represents a category of data, and the size of the sector will represent either the frequency or it will represent the relative frequency most likely. So usually you use these when you have relative frequency because they give nice percentages. I can look at this red chunk right here, which my star kind of blends into, and I can say, hey, that's the biggest chunk, so probably most people proportionally voted for romance in this case. Now, when I ask you to make any of these, just make sure you're clearly labeling everything. For instance, on your bar or Pareto graphs, make sure that you are labeling the horizontal axis well with your categories and the vertical axis well with either your frequencies or your relative frequencies, On a pie chart, make sure that you're clearly labeling each sector and that each sector is proportional to the frequency. Meaning, hey, this 5% vote should not be the same size as this 30% vote down here. Now that's it for 2.1. Like I said, a lot of it is just going to be bar graphs and pie charts. But most importantly, what you learned in this section was how to make a frequency and a relative frequency distribution. Frequency distributions are just charts displaying tallies. Relative frequency distributions are charts that display, your proportion or percentage. Know how to get from a frequency to a relative frequency distribution? Hint, add up all the tallies to get the total and divide each frequency by the total, because that will come up on the exam. But other than that, try out the homework. Best of luck to you. See you next time. Bye.